So these equations some people were struggling with. Remember, we're solving this. This is going to be just like having an equation like 5x plus 2 equals 32. The first step over here would be to subtract the 2. Well, over here, what's the first step going to be then? Subtract the 3.6. So 2.1x equals, what does that come out to be, 4.8? Then what would be our next step? We divide by the 2.1. So 4.8 divided by 2.1 ends up giving us 2.2857143 approximately. Okay. Now, here's where you were asking. What if I ask you to find this to the nearest hundredth? And you want to divide that out by hand. So this is 4.8 divided by 2.1. First thing we have to do, get rid of the decimal point in our divisor. So we're going to have to move it over one spot here. So we're going to move it over one spot here. So this becomes 48 divided by 21. 21 goes into 48 twice. 2 times 21 is 42, which leaves us with 6. Now, before we would stop there, we just have that remainder of 6. But now we know that we can keep going. To keep going, we have to add a decimal point. Then I have to bring that decimal point up before I do anything else. Then I can add a 0 here and bring down that 0. So now I have 21 goes into 60. Well, it's still going to be twice. That's 42, and there is 18 left over. Well, now we're at tenths, right? We're going to be going to the nearest hundredth. So I'm going to add another 0 and bring it down. 21 into 180. Let's go 8 times. 8 times 21 is 168. Leaves us with 12. Now that's the hundredths place right there, but we can't stop yet. We have to go one digit beyond. So we have to add one more 0 and put it in. 21 into 120 goes 5 times. 5 times 21 is 105. There's 15 left over. The reason we had to go that extra place here, past our hundredths, is because we need to know, is that going to stay 2.28 or is it going to round up to 2.29? That 5 does tell us we're going to round up to 2.29. So that is 2.29. No, the answer is the 2.29 because we do have to round it back to the hundredth. But we have to go one digit past so we know where to round it. You were leaving it with the extra digit on the end?
Yeah, like the answer was 2.285 because I want the extra place.
Yep. Okay. Yeah, you do have to round it back to that.
What about with the fractions like on the homework today? It was a whole number and then 8 over 17 or something like 8.
Okay, 8 over 17 sounds right. To change that into a decimal.
But you need the whole number alone.
Well, we're going to set it up like that. 17 goes into 8. Now we've got to add a decimal point and bring the decimal point up. And add a 0. 17 goes in, now did they say round to the nearest hundredth or whatever? To the nearest hundredth. So again, we're going to go to the nearest hundredth here. 17 goes into 80 4 times. That would be 68. And we subtract. It's going to leave us with 12. Oops. 12. Now we're going to add another 0 and bring it down. It's 120. 17 goes into 120 7 times. That's going to be, what, 119? Leaves us with 1. We do have to add another 0. We're at the hundredths place. We have to add another 0 and keep going. 17 does not go into 10, so that's going to be 0 there. So that's going to stay just 0.47. You look confused.
No, I just get myself confused with place value. It's like
Okay.
after the decimal point, when you said 0.47 is the hundredths, I always
Yep.
go ones, tens, hundredths.
Okay, yeah. Remember, before the decimal point, it's ones, tens, hundredths. After the decimal point, it's tenths, hundredths. There's no ones after the decimal point. Okay. Well, our new stuff for today, we're going to start talking about percents. And to really understand percents, we need to understand the word percent. Percent is really made up of two words, per and cent. Per, if you think of like miles per gallon, miles per hour, dollars per hour. Per means for each or out of. And cent, you think of years in a century or cents in a dollar or centimeters in a meter, it means 100. So the word percent literally means out of 100. So if we have 68%, that symbol, of course, is our symbol for percent. That means 68 out of 100. It's actually a ratio. In fact, it is that simple to change a percent into a fraction. Take the percent, you put it over 100, it's now a fraction. Now, of course, we would not leave that as 68 over 100. We would reduce it. Both 68 and 100 can be divided by 2. Gives us 34 over 50. And we can still divide by 2. We have 17 over 25. So 68% means 68 out of 100, or reduced to 17 out of 25. So if we have 35%, that means 35 out of 100. Both of those can be divided by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. So that is 7/20. What if we have something like 240%? Well, yep, that's still 240 over 100. And then we can reduce from there. Percent is always out of 100. That's the definition of percent. Well, the first thing I would do is, since this is an improper fraction, the numerator is larger than the denominator, I would turn it into a mixed number. 100 goes into 240 twice, with how many left over? 40. So that's 2 and 40 hundredths. Now the 40 and 100 can both be divided by 5, 10. Let's do 10. Cross off a 0, so that's 4/10. Those can still both be divided by 2. Give me 2/5. Now you notice I left a space here because I have to remember to bring my whole number over. That is 2 and 2/5. Yeah. Zero. Yeah, that's what I would normally do. Divide out the 0, cross off the extra 0. Yeah, it makes it simpler that way. So 2 and 2/5. So I'm going to have you guys try one in your notes quick. I'm going to give you 385%. Turn that into a fraction for me. So 385% is 385 out of 100. If you wanted to reduce by 5 first, you could, but I'm going to go ahead and just take out the 100. 100 goes into 385 3 times with 85 left over. Now we can reduce both the 85 and the 100 can be divided by 5. 85 divided by 5, 17. 100 divided by 5, 20, and still have the 3 on front. 3 and 17/20ths. Now it's this one that we just did and this next one that people get confused. (87.5% is 87.5 out of 100. Now, we don't like having that decimal within our fraction, do we? So to get rid of it, we do just like we did when we were dividing our decimals. We move the decimal point over. Remember, what we were really doing there was we were multiplying by 10 or 100 or by 1,000. This only has one decimal place, so we're going to multiply by 10. 87.5 times 10 is 875. So, of course, we have to multiply the denominator by 10 as well. 100 times 10 is 1,000. Now, be careful here. A lot of people want to jump to this second step and put it over 1,000 right away. Always start out with the over 100 and do your adjustments from there. It'll save a lot of mistakes. Because what happens is people look at this one and they say, oh, there's 3 digits there, it's got to be over 1,000. It's not true. Percents always start out as over 100. And so don't try to skip those steps, because I see a lot of mistakes made on these decimals because of that.
So we kind of the decimal percentage, and then we kind of put into a fraction.
Starts out as over 100. And then if there's one decimal place, you multiply by 10. If there are 2 decimal places, you'd multiply by 100. 3 decimal places, you'd multiply by 1,000. So here we have the 875 over 1,000. Both of those can be divided by, let's do 25 first. 875 divided by 25 is 35. 1,000 divided by 25 is 40. Both of those can still be divided by 5. Give us 7/8. We might have 31.25%. Well, that's going to be 31.25 over 100. Now, here we have 2 decimal places. So what do we have to multiply by? 100. Going to move it over 2 spots. So that becomes 3,125 over 10,000. Now, both of those can be divided by what? 25 will work again. 3,125 is what? 125. 10,000 divided by 25 is 400. Both of those can still be divided by 25. 125 divided by 25 is 5. 400 divided by 25 is 16. So 5/16. 31.25% is equivalent to 5 out of 16. So let's have you do 56.25% quick. So we start out as 56.25 over 100 again, as always. Every percent is out of 100. What do we have to multiply here? 100, because there were 2 decimal places. So it's 5,625 over 10,000. And I'm sure all of you could see right away that both of those can be divided by 625. Sure? Probably divided by 25 first to get, what's that come out to be, like 225 over 400.
Do you care, like on the written test, if we divide it out, even though there's a bigger number you can divide it out?
No, just divide it out. I mean, personally, I probably would have started dividing by 5 or 25 here myself. It divides out to be 9/16. In fact, your calculator should reduce this for you. You've got the ABC button on there, right? If you put 5625 ABC, then put in the 10,000, 9/16. The older version of that calculator would not accept the 5 digits in the denominator, but now they do in the newer versions. They can reduce those. No fraction key on the graphing calculator. As you can see, mine doesn't do fractions. I have to force it a little bit to make it do fractions. Well, yeah, it won't. Well, actually, this calculator will reduce that if I did 5625 divided by 10,000. Bless you. I can divide it to get the decimal. Bless you again. Then I can go into the math menu. There is a convert to fraction function. So this calculator will give me that one as a fraction. What's that? It won't do it the easy way. It'll convert everything to decimals first, then you got to convert them back to fractions. No, there's actually the TI-83 and TI-84 series was made for statistics. The TI-81, TI-82 series was made for algebra. Now with the TI-84 Plus, they kind of melded the TI-82 into the TI-84, so they don't even make the TI-82s anymore. They do make a TI-85, TI-86, which is scientific. It's made for physics and engineering, so it has all of your natural constants and stuff pre-programmed into it. Then they have a TI-89, which actually works with variables. So you could actually put in x squared times x to the 8th, and it'll give you out that's x to the 10th, and so on. The problem is figuring out how to enter it in there is more difficult. For me, it's more difficult than to just do it.
Do you need a special calculator for math?
No, the one you've got there is probably the best one to use. Yeah, these are like 120 bucks. You don't need the graphing calculator now. For you, if you take any like your personal finance class or your accounting class, sometimes they ask you to get a business calculator, a BA, a Texas Instruments BA calculator. Most of what you need that for you can do on the TI-30. The BA calculator just has some amortization and some annuity functions built into it, but it's the same type of thing. Figuring out how to enter it in the calculator to me is more difficult than just entering the formula. Okay, so our next step then is what if I have 36 2/3%, and I want to make that into a fraction. Well, that's 36 2/3 over 100. Now, before we had decimals within our fractions, which we didn't like. Now we've got a fraction within our fractions, which we definitely don't like. We have 2 options to do this. Option 1, well, I guess there is that third option of not doing it. In this class, you always have the option to not do something, but I have the option to take away points too.
Don't you have the option to like not take a homework and take the other place and have
I do. So, the first option is to get rid of the fraction. So we look at common denominators. Well, the only denominator here right now is what? I mean, we have the 100, but I mean, we have the 3. It's really the only denominator in between the numerator and denominator numbers. So the denominator here is 3. So to get rid of our fraction, I can multiply both my numerator and denominator by 3. Well, 100 times 3 is 300. That part's easy. 36 2/3 times 3. Well, 36 2/3 has to be changed into an improper fraction. So 36 times 3 is 108, plus 2 is 110 over 3, times 3 over 1. I'm going to cross cancel the 3's. You don't have to. That just gives you 110. If you didn't cross cancel the 3's, you'd have 330 over 3. Then you'd do 330 divided by 3 gives you 110. So you'd get that 110. So right now this is 110 over 300. Both of those can be divided by 10. Gives me 11/30. So 36 2/3% is the same as 11/30. Option 2 is to simply divide it out. A fraction can be thought of as a division problem. So 36 2/3 divided by 100, but dividing it out as fractions. So that becomes 100 over 1. 36 2/3 still has to be turned into an improper fraction. 36 times 3 is 108, plus 2 is 110. So it's 110 thirds. Instead of dividing by 100 over 1, we're going to multiply by 1 over 100. So that's 110 over 300, which is where we just were. Both of them divide by 10. It's 11 over 30.
First way is multiplying it
By the denominator, yes. To eliminate the denominator. Like I said, they both get you the same spot.
What is 36 2/3 over?
Remember, it's always, since it's a percent, it's always going to be over 100. What if we want to go to a decimal? What if we have, let's go back to our start here, the 68%, and I want to turn it into a decimal. Well, remember we said 68% means 68 out of 100. And if I want to turn that into a decimal, it's just 68 divided by 100. Well, when I divide by 100, what does it do to my decimal point? It moves it 2 spots to the left. So that is 0.68. So 68% becomes 0.68 as a decimal. Because the percent is out of 100, a decimal is out of 1. So to turn a percent into a decimal, we're always going to be dividing by 100. And since dividing by 100 just moves that decimal point 2 spots, we can just move the decimal point 2 spots. So for example, 31% is going to become what as a decimal? 0.31. 79% is going to become 0.79. 60%. 0.6, 0.60, however you want to word it. How about 8%? 0.08. Good. Dividing by 100, that decimal point has to go 2 spots yet. 300%? Just 3. That decimal point has to move 2 spots. So dividing by 100 is just going to be 3. 170%. It's 1.7 or 1.70. Well, here that 0 makes a difference. It has to be there because it's 0.08. But here I could have put a 0 there, and I did, or I could leave it out. It doesn't matter. You know, 0.6 or 0.60, I don't have to worry about it. Same here. I could leave 1.7 or 1.70. It really doesn't matter.
0 doesn't matter when it goes after.
When it's at the end after a decimal. Yeah. 2.8% is going to become what as a decimal? Perfect. 0.028. Because we still have to go over 2 spots from that is 0 in there. 326.9%. Perfect, 3.869. So we're just dividing by 100, or, like I said, moving that decimal 2 spots to the left. So now if we want to go from a decimal back into a percent, if I have 0.43 as a decimal, remember that means out of 1, and a percent means out of 100. So the easiest way to look at that is to say, well, if I want to turn 1 into 100, I have to multiply by 100. So I have to multiply my numerator by 100 as well. 0.43 times 100 is 43. That's 43 out of 100, or 43%. So to go from a decimal back to a percent, we're multiplying by 100, or just always moving that decimal point 2 spots back to the right. So if I have 0.91, that becomes what as a percent? 91%. 2.7 becomes what as a percent? 270%. Good. 0.064 becomes what as a percent? 6.4%. 2 spots to the right. Exactly. From percent to a decimal, it's 2 spots to the left. Decimal to percent is 2 spots to the right. But it's multiplying by 100 or dividing by 100. Changing a percent into a fraction is a little bit more difficult. So I'm going to start with one that I think pretty much everybody would know. I'm sorry, a fraction to a percent, I should say, is a little bit more difficult. So let's start out with 3/4. What percent is that? 75%. Now, if you didn't know that, there's a couple of ways we could go. We could do 3/4. We could divide it out to make a decimal. 3 divided by 4 is 0.75, and then move the decimal point to make it 75%. Which works out just fine in most cases. The only place it gets ugly is if it's a repeating decimal or a non-terminating decimal that goes on for a ways. You got to divide it out and round it off before you turn it into a percent. The other way we could do it is this. 3/4 can be thought of as 3 out of 4. A percent is always out of 100. So asking how much is that out of 100? Then we can cross multiply and divide to find that missing number. 3 times 100 is 300. Divided by 4 gives us 75. So 75 out of 100 is 75%. Yep, divided by 4. So if I have 5/8, I want to turn it into a percent. So 5 out of 8 is equal to blank out of 100. So we cross multiply. 5 times 100 is 500. Divide by 8 is 62.5. So 62.5 out of 100, or 62.5%. Not so bad?
So when it's already a fraction, like 62.5 over 100,
Yep.
you don't have to do anything to get the percent.
Nope. If it's out of 100, it's already a percent. For example, if I said that out of 100 students, 18 failed. What percent failed? Well, that's 18 out of 100. That's just 18%. Or we might say out of 50 students, 12 had A's. What percentage had A's? Well, 12 out of 50, it's pretty easy to turn that into You double the 50 to make 100, you double the 12 to make 24. So 24 out of 100, which is 24%. Now, something I want to talk about briefly here is benchmarks. And benchmarks work with percents that are pretty easy to deal with. For example, 10%. 10% is 10 out of 100, which reduces to 1/10. To find 1/10 of something, you would just move the decimal point. For example, if I wanted to find 10% of 240, that's 1/10 of 240. I just move the decimal point over one spot. That'd be 24. One percent means 1 out of 100, or 1/100th. If I want to find 1% of something, 1% of 4,800. Well, 1% is 1/100th. So dividing by 100 means I just move the decimal point over two spots. That would be 48. Is 1% of 4,800. So when I have a number, I can very easily find these benchmarks. So if I have the number like 3,100, 3,100, what's 10% of 3,100 going to be? 310. Just move the decimal point over one spot. What's 1% of 3,100 going to be? For 31, right? Just divide by 100, move the decimal point over two spots. See, 10% and 1% can be found by just moving the decimal points. So if I want to find 12, well, 10%, you move it over one spot. So it went from 3,100 to 310. Because 10%, remember, is 10 out of 100, or just 1/10. 1% is just 1/100th, 1 out of 100. You look confused.
Yeah. Maybe so.
10%, remember, means 10 out of 100. Cross off the zeros, it's just 1/10. So 10% means just divide it by 10. That's moving the decimal over one spot. So 10% of 240 is 24. 1% is 1 out of 100, which is just dividing by 100. So 1% of 4,800 is 4,800 divided by 100. You move the decimal over two spots. So if I want to find 12% of 3,100, I can think of 12% as 10% plus 1% plus 1%. 10% we found to be 310. 1% is 31. I add that up, I have 372, which is 12% of 3,100. So I can find that really quickly. The biggest application of this is in restaurants, where you're asked to tip. Let's say you want to find 20% of a $43 bill. Yeah, 10% is going to be 4.3. So another 10% is another 4.3. That, 4.3. So that would be $8.60 would be your tip on a $43 bill. Yeah. Yep. And exactly, like 15% of, let's say, 15% of something that's marked $84. Well, 10% is 8.4. 5% is half of that. That'd be 4.2. So that's $12.60 off. Make sense? I mean, I do a lot of percents this way with benchmarks. Now, the other thing benchmarks does is it gives you, we talked about that estimating back in the first couple of weeks of class, where before you punch it in the calculator, have an idea. I mean, if I'm looking for, let's say, 18% of 43, well, I know 20% is 860. So no, 18% better be just a little bit smaller than that. So I have that benchmark to compare to. The other place benchmarks come in, what if I were to ask you to convert 1/4% to a decimal? What would you say that is? I'll warn you, a lot of people would jump in and say 0.25%. But there's a problem there. What's 1% as a decimal? 0.01. 1/4 is smaller than 1, isn't it? So 1/4% as a decimal better be smaller than 0.01. 0.25 would still be a percent. Just change it from a fractional percent to a decimal percent. To change it to just a decimal, we still have to go 2 more spots. So 0.0025. Which makes sense. It's smaller than the 0.01 from the 1%. This is something we'll go over a little bit more tomorrow. Tomorrow we'll actually look at calculating exactly then, rather than doing these estimates and benchmarks. There is a new quiz that is due tomorrow. That's Thursday, 11:59 p.m. And there is a new homework. It'll be due on Monday. And remember, we do have test 3 coming up. Next week, Thursday, is test 3. We haven't decided yet whether we're going to do it Thursday. We might push it up to Wednesday. We'll see how things go in the next couple of classes. It is coming up. I just looked at it, and there's not really enough material to fill the whole class on Monday, so we might do the review at the end of class Monday and test Wednesday. Let's do that.